we hear this term quite a lot. The term is drop-in lithium replacement, or drop-in replacement for lithium. So standard, probably AGM or lead acid flooded batteries on the boat, and a manufacturer has promised that they can just swap the battery out. What does a drop-in battery replacement mean to you for lithium, and what are the implications that come to mind?
Well, there's a lot of people that do it. They pull out a lead acid battery and they replace it with a lithium ion battery. But from my perspective, there's no such thing as a drop-in lithium ion replacement for lead acid because there's the parameters, the operating parameters, and the safe operating envelope, what we call the SOE, for lithium ion are different to lead acid. So a lithium ion battery has to be integrated into the electrical system on the boat. And in fact, I tell people that they shouldn't think of it as a battery. It's an energy storage system. And the emphasis there being on the word system, which means that you've got to tie it into the charging devices, and you've got to look at the maximum amp draw on the boat. There's a whole lot of issues that you've got to take into account, the maximum temperature, the lowest temperature you might see, that you really don't have to with a lead acid battery. The lithium ion is more persnickety, and it needs more control capabilities, and you simply won't get that with a drop-in battery. And it may function just fine, but on the other hand, it may get you into trouble. And there's no real way to tell which end of the spectrum that's going to be, the okay or the troublesome, without actually looking at the whole application and making sure it's engineered properly. You may get lucky and you may not. And we shouldn't be trusting to luck when we put these bits of equipment on a boat.
No, it's too much at play. And it's so disappointing to have a boat system. Like I had a boat owner did exactly the drop-in, was sold the drop-in, promised the drop-in, underway, motoring for long periods of time, which a lot of people do here because, the wind's coming direct or there's no wind and you got a motor. After 10, 11 hours of motoring, the battery went into a protection mode and they literally ended up having no house battery. And no house battery is a big deal.
Yes.
They were able to find ways around it, but those batteries, when they came back to the city, those batteries went out and were changed for something different, something with more consideration. And you're right, the things that are too good to be true, as we've learned in life, are generally too good to be true. And we might chase them, but sometimes we got to be willing to be disappointed. Any other sort of common issues for you? Like for us, when we do lithium, we're thinking about what's going to happen.
Well, yes, Jeff, there's one other that comes to mind, which is if you replace a lead acid battery with a lithium ion battery, and then you deeply discharge that lithium ion battery, it's going to have a higher long-term charge acceptance rate than the lead acid battery. The lead acid battery might have a very high charge acceptance rate for maybe a half an hour, and then it's going to taper off. The lithium ion, if it's well discharged, will push your charging devices to full continuous output for potentially hours at a time if it's a big battery bank. And then you're going to stress out all of the conductors, the electrical circuits. So then you have to think about whether the conductors are the right size and whether the overcurrent protection is okay. And are you going to fry that alternator? If it's a standard alternator that came with the engine. For example, Yanmar some years ago put out a bulletin that if you put lithium-ion batteries on the boat, you had to derate their alternators, and they didn't tell you how to do it because there is no easy way to do it, but you have to derate their alternators to 75% of their rated output because otherwise you had a risk of frying the alternator. So there's a whole series of peripheral issues that have to be addressed with these installations, which again comes down to the fact there is no such thing as a drop-in lithium-ion battery, from my perspective.
I agree. I think I mean, there's no harm in thinking, right? Like you've got to understand the implications of a choice. You have to. I mean, hope, as you mentioned earlier, is not a substitute for preparation. We might all hope for the same outcome. The ones that get there with a higher degree of certainty are the people that prepare for that outcome by avoiding the many pitfalls that we've learned over the years with lithium. batteries, including, how do you share one alternator with a star charge profile, charging a lithium, like you said, overtaxing the alternator, running at a high output for extended periods of time, burning out that alternator. There's so many different little things that you want to think about as a boater when you put in lithium, even though the manufacturers say, some of them say it's just so easy. Unfortunately, in my opinion, it never is truly that easy, albeit it's doable. It's doable if you sort of read up and prepare and think about the contingencies that might arise from the installation. And you mentioned another one too about heat earlier, or low temperature here in the Pacific Northwest. We've seen that, and that's a real issue. Boats that are on trailers, and they're on this outside and it's 0 degrees Celsius, 32 degrees Fahrenheit, it drops to -5, maybe 20 degrees Fahrenheit. Those are real issues that might happen here in the Pacific Northwest with boaters that are actually, the boats are not in the water and the batteries do get to below freezing sometimes. Like right now, it does happen. And that's also something, another consideration for going with lithium as well. Yeah. Lots to think about, but it's doable.
Layups. A lot of boats, get laid up for months at a time. If you've got some minor parasitic load and you discharge that lithium-ion battery down to its shutdown threshold, there are many of them in the marketplace where you can't just plug them back in and recharge them. They actually have to go back to the manufacturer. It's quite likely you've discharged one cell more than the others, and it's down to a point at which it's not really safe to recharge it without specialized equipment. So, and again, with lead acid, we can discharge them totally dead, and most times we can just plug them back in and recover them. Lithium ion, you may not be able to recharge it. You may have to send it back to the manufacturer. So there are all these sort of small differences that add up to quite a big difference in practice.
Yeah, good. Well said. Life's not easy. It's a boat. If it was easy, it wouldn't be a boat. It's like golf. If it was in hard, it's not golf. It's just, there's no way around it. You're going to be humbled, and it's part of the journey. It's just part of the journey. It's just, that's what it is. It's what it takes to earn your stripes, to be out there enjoying the beauty of the water and everything else, the scenery. It's not going to be, there's going to be bumps. Yeah. Prepare for it and avoid them as much as possible. All right. Well, thank you, Nigel. Anything else you want to add on that? Or does that give a little good wrap up for people to start educating themselves more a little bit on lithium?
No, I think that's good to go. Thank you, Jeff.
So if you're curious, again, go on our website and find out more answers and solutions with this sort of setup. And thanks for asking. And thanks for all of you for listening and tuning in.